Hi, I'm Ken of Rist Innovations, and today I'm excited to show you how you can enhance your 3D prints using a laser engraver to cut thin wood and apply the wood to your 3D prints that will really make them pop. I'll show you how I used a Creality Falcon 2 22-watt laser engraver by installing the laser, an exhaust system, a computer, and Lightburn software to run the laser. I'll show you everything you need, including the laser engraver's key features, setting up the engraver, and how I made several styles of 3D printed boxes using the engraver. I want to thank Z-Banks for sending me the Creality Falcon 2 22-watt laser engraver. So let's get started. This is a 22-watt diode laser. Creality also makes a 40-watt diode laser. The Falcon 2 engraving cutting area is 400 millimeters by 415 millimeters, and there are adjustable legs that can be attached to the bottom to increase the height of the laser. The Falcon 2 can cut and/or engrave cardboard, wood, rubber, leather, fabric, colored acrylic, and metal. It can cut 15 millimeter thick wood and 10 millimeter black acrylic in one pass. Just a note, diode lasers can't cut clear acrylic. It has a maximum speed of 25,000 millimeters per minute, and it has an integrated air assist. This integrated air assist removes smoke near your workpiece, so it protects the laser lens and it makes a cleaner cut. You can manually adjust it with the thumb wheel and also automatically adjust it through the Lightburn software. There are three monitoring features on the laser. The airflow monitor ensures proper airflow to the workpiece. The lens monitor will trigger an alarm if the lens is dirty. And the flame monitor will sound an alarm and immediately stop the machine if a fire is detected. The Falcon 2 has 5 safety features. First, limit switches will stop the machine if the laser module hits the boundary. It also has a tilt sensor that will detect if the laser gets accidentally tilted or dropped. The alarm will sound and the laser will stop. There's also a security lock to prevent children or others from turning on the laser. And there's an emergency stop button, which allows you to quickly turn off the laser in an emergency. The laser module also has a protective cover that is mounted to the laser head to reduce laser reflection. The Falcon 2 does not come with application software, but it is compatible with Laser Gerbil and Lightburn application software. You can operate the Falcon 2 by either using a computer or offline using a micro SD card. For me, I decided to install a computer at the Falcon 2 and install Lightburn software on the computer. Lightburn is used by many people running laser engravers, and at only $60, I think it's a great value for the features of the software. A link is in the description below. The laser also has an integrated cable storage, which allows cables and the air hose to be neatly organized within the laser. At the making of this video, January 2024, the current pricing of the Creality Falcon 2 22-watt laser engraver is $719. The basic combo kit costs $934, and that includes a 500 millimeter square bottom plate and honeycomb, a laser enclosure, and some material samples. The premium combo kit costs $851 and includes a 500 square bottom plate and honeycomb, a laser enclosure, and a rotary engraver attachment. The Falcon 2 is well protected in its packaging. It's pre-assembled right out of the box, and it only takes a few minutes to attach the legs, air assist, and laser module. The basic unit comes with a 320 millimeter square aluminum plate and honeycomb platform. The honeycomb platform elevates your object to cut to allow the laser to pass through the bottom of the part, and it allows the exhaust to pull the smoke away from the part. Otherwise, if you tried to cut a part directly on the aluminum plate, the smoke residue will accumulate on the bottom of the part, and heat buildup can damage the bottom of your part. A critical component is the aluminum plate, which protects the tabletop surface from the laser. If you don't install the aluminum plate, you could burn a hole right through your dining room table, which was not going to make your spouse very happy. Plus, it's a fire hazard. I have the optional 500mm square bottom plate and honeycomb panel, which allows me to use the full capacity of the laser. This comes in the combo units I mentioned previously. Speaking of 3D printing, if you have a 3D printing need, but you don't have a 3D printer, I've got a solution for you. That brings me to the sponsor of today's video, PCBWay. If you're working on any prototype projects, they can help you when you need a variety of parts. Besides making PCBs, they also offer CNC machining, sheet metal fabrication, injection molding, and lots of different types of 3D printing, including metal 3D printing. I recently needed a metal 3D printed part out of stainless steel, and I went on their website, uploaded my design, selected the material and quantity, and got an instant quote. Then they manufactured the parts and shipped them within 9 days and right to my door. Give them a try, and I think you'll be amazed at what they can do for you. I have a link in the description below. Now, back to the show. Eye protection. The basic unit is an open design, which means you can be exposed to the laser, which can damage your eyes. So it's critical that you wear laser-approved goggles. Creality includes a basic pair of laser glasses. However, I purchased this pair of laser goggles that fully protect my eyes. They are very comfortable and they're certified for this laser's 455 nanometer wavelength. A link is in the description below. It's critical that you exhaust the fumes from the laser engraver because you don't want to be breathing the smoke and other contaminants. I've seen some YouTubers that run their laser engravers in their garage and they open their door for ventilation. But for me, I wanted a more effective and powerful way to exhaust the fumes. An enclosure is included in the combo package, and I feel this is critical to manage the fumes from the laser. It should be viewed as a secondary protection, so you should always wear your laser goggles, even if you have the enclosure. I wanted a stronger exhaust fan than what came with the enclosure, so I purchased and installed an AC Infinity 6-inch diameter inline exhaust fan that generates over 400 cubic feet per minute airflow. So this thing can suck the paint off the wall. It has 10 speed settings and it's relatively quiet. A link is in the description below. I made a permanent installation through my wall, but you could also make a panel and install it in a window. I mentioned earlier that the Falcon 2 can be run using a micro SD card, but I wanted to have a computer right next to the Falcon 2 so I could easily make changes to my designs, make material test grids, and more easily operate the laser engraver. I installed Lightburn software, which for only $60 is a very versatile application software. Initially, you need to tell Lightburn what laser you have. So in my case, there's a file on the micro SD card that I imported into Lightburn, and I needed to choose which COM port in the computer that I connected the laser to. Okay, now let's make some parts. For my first part, I chose to make the Creality image on a piece of 2mm thick basswood plywood. I used the focus block to set the correct height of the laser module. Creality provided a file that contains the two main parameters, laser speed in millimeters per minute and laser power in percent for a variety of materials. For 2mm basswood, Creality recommends engraving basswood at 30% power and 6,000 millimeters per minute and cutting at 100% power and 700 millimeters per minute. I hit the frame button, which will show you the outline of where the laser will be engraving or cutting. So it's a matter of moving the basswood plywood until it's completely under the path of the laser. I turned on the exhaust, then I just hit the start button. The laser will do the engraving first and then cut out the part. The part turned out great. Now let's make a shaker box. I made my first shaker box almost 20 years ago. It's called a shaker box because the original design came from a religious cult from the 1700s called the Shakers. They designed simple, functional furniture and housewares, and they made these boxes in many different sizes to store seeds and other small items. I made both these shaker boxes. One is made the traditional way by steam bending thin wood around a form. The other one I made using my 3D printer and the Falcon 2 laser engraver. Can you tell which is the 3D printed one? It's this one, made from real walnut veneer wood. Now, I'm going to show you how I made it. I designed the 3D printed shaker box using Fusion 360. The veneer is approximately 0.94 millimeters thick, so I designed this recess to fit the veneer. I printed the box body and lid out of Bamboo Lab black PLA. I designed this shaker style pattern in Fusion 360, and I bought this software plugin from Icarus Soft Landings that converts Fusion 360 sketches to SVG file format, which is a popular file format for laser engravers. Link is in the description. I needed to determine what laser settings I needed in order to cut the veneer. The Lightburn software has a great material test feature, so you can determine the best power and speed settings for engraving and cutting materials. The first thing I did was to see if I could find a similar material on the Creality recommended settings list spreadsheet. The closest thing was a 2mm thick basswood plywood with a recommended speed of 700 millimeters per minute at 100% power. I designed a Lightburn test grid with the following parameters: a minimum speed of 1,000 millimeters per minute and a maximum speed of 2,000 millimeters per minute in 5 increments, and power from 10% to 100% in 10 increments. Lightburn recommended to place a piece of glass over materials that warp because you want to always keep the workpiece flat so you get consistent engraving and cuts, and because the parts can curl up otherwise and get caught in the laser module and sometimes even catch fire. Glass works for diode lasers because the laser goes right through the glass. The problem I found is that although the glass kept the veneer flat, it trapped the smoke and it caused a lot of discoloration in the wood. Plus, I couldn't find a power/speed setting that cut through the paper but didn't damage the veneer. Eventually, I gave up on the glass and I used these large rare earth magnets, which worked really great to hold down the veneer. A link is in the description. I used a setting of 900 millimeters per minute at 75% power to cut the veneer. I sanded the box to have a better mechanical bond with the veneer adhesive. Then I wrapped the main box, applying pressure to help bond the veneer to the box. Then I drilled some 1/16 of an inch diameter holes and glued and hammered in these 1/16 inch copper rivets. I made the veneer slightly oversized and then I sanded the edges flush. I attached veneer to the lid and then wrapped veneer around the edge of the lid and added copper rivets just like I did for the main box. Then I cut some 1.2 millimeter thick adhesive backed felt for the bottom of the box. I set up a Lightburn test grid similar to what I did for the veneer, only this time I used settings of a minimum speed of 2,000 millimeters per minute and a max of 6,000 millimeters per minute in 5 increments, and power from 10% to 100% in 10 increments. The best setting was 3,000 millimeters per minute at 70% power. Lastly, I added 4 coats of Wipe On Gloss polyurethane finish and added the felt to the bottom. I think it turned out beautifully. Next, I designed this round box with the idea to showcase the 3D printed look, but to accent the boxes with various real wood veneer for the lids. I designed the box in Fusion 360, and I designed the lid into two pieces, so I wouldn't need to have any overhang. I designed one version to have a through hole and a knob, and the other version of the lid to not have any holes that would get in the way of any engraving or the actual design of the lid of the box. I 3D printed several variations of the boxes using various Bamboo Lab PLA filaments, including gray sparkle, black, white, silver silk, gold, and silver metal. In all cases, I used a 0.4 millimeter diameter nozzle and a 0.12 millimeter layer thickness. I have a variety of real wood veneers that I glued to 3 millimeter thick basswood plywood using contact cement. Here is some zebra wood, bird's eye maple, padauk, and walnut. I used the light burn material test generator to first determine the best settings to cut the basswood plywood. Creality recommends 100% power and 700 millimeters per minute for 2 millimeter thick basswood plywood. So I set up a test using a minimum of 250 millimeters per minute and a maximum speed of 650 millimeters per minute in 5 increments, and a power from 10% to 100% in 10 increments. Based on my test, I decided that a speed of 450 millimeters per minute and a power setting of 80% would be an optimal cutting setting for the 3 millimeter bass plywood. I also wanted to make some lid variations by using a marquetry technique. Marquetry is when you take thin wood veneer and you cut patterns and then fit the individual pieces of the veneer to create a design. I took a class on marquetry several years ago, and the technique I learned was to cut the pieces out using a very thin bladed scroll saw. This is a jewelry box I made using that technique. I wanted to see how easy it would be to use a laser to cut the veneer parts instead of the scroll saw. My veneer is approximately 0.58 millimeters thick, so I compared the Creality basswood plywood at 2 millimeters, and Creality recommends 100% power and 700 millimeters per minute. So I set up a cutting matrix of 1200 millimeters per minute to 1600 millimeters per minute in 5 increments, and 10 to 100% power in 10 increments. Based on my test, I decided that a speed of 1200 millimeters per minute and a power setting of 50% would be an optimal cutting setting. I cut a compass design in walnut. Then I designed the insert at first 20 thousandths of an inch larger offset, which was too large. Then I tried a 15 thousandths of an inch offset, which was closer. And finally I tried a 10 thousandths of an inch larger offset, which was perfect. The offset compensates for the kerf, or the width of the laser beam that burns the veneer. I applied Scotch tape to the front of the veneer, and then I applied contact adhesive to the back of the veneer and the basswood plywood. Waited approximately 20 minutes, and then I applied the veneer to the basswood plywood. I used a roller to apply pressure to make a strong bond of the veneer to the basswood plywood. Then I applied 4 coats of white bond polyurethane gloss varnish. I cut the jewelry box lid inserts using the 450 millimeters per minute speed and 80% power. For engraving the wood inserts, I first looked at what Creality recommends for engraving in basswood plywood, which was 30% power and 6,000 millimeters per minute. I set up another light burn material test generator by choosing 3,000 millimeters per minute to 15,000 millimeters per minute in 10 increments, and a power setting of 10% to 100% in 10 increments. I concluded that the 30% power and 6,000 millimeters per minute works well, which is what Creality recommended. I also cut some adhesive-backed felt to line the bottom of the jewelry box. I ran another light burn material test generator matrix and determined that the best setting is 3,000 millimeters per minute and 70% power. I really like how the various veneers, engravings, and different PLAs are combined to create many different looks. I feel like I'm just scratching the surface on how I can incorporate wood veneer into my 3D printed designs. Where do you see how a laser engraver could enhance your 3D printed parts? Please leave a comment below. Also, let me know in the comments if you would be interested if I was to develop a line of kits where you could 3D print the parts and then I could sell you the various laser cut components and hardware. If you found this video useful, please consider subscribing to my channel. My next video will be a deep dive on the rotary attachment for the Creality Falcon 2 that will allow me to engrave and cut cylinder-shaped 3D parts. So when that video is available, that link will be here. In the meantime, you may want to watch my top 10 bamboo upgrades for the X1 Carbon P1 series of printers, and that link is here. Thanks for watching. Bye!